Hello, LogiWiki. I will try to explain in this video how um, Microsoft Surface Laptop 3 charging system works, because it was quite hard to fix simply because it is not standard. It's not like on Mac devices. Very similar in some uh, parts, but very different from everything I've seen before. So this particular device came with a little water damage, so it was something around battery charging circuit, and there was also damage in the connector. So it came to me already clean, so I didn't see the original damage. I just suppose there was something to the keyboard. So this laptop is a one which is not glued anymore. So it has a metal shield with a magnets on the bottom case, and it's quite easy to remove, quite easy to open. It also has trackpad slash keyboard cable, which steps here with magnet, so really easy to service. Um, so I will just try to keep it short. So the first difference is a different battery. It uses inverse, or better to say like straight enable signal. So to be enabled, unlike many other batteries, it needs 3 volts on the enable signal. It also has more enable signals like detections on that signal and battery wake signal. This battery doesn't provide any voltage in standby mode, so it just outputs 3.0 LDO. So the BMC board has some sort of power regulator which generates 3.0 volts, which supply all the like cold state circuits in logic board. Um, the second thing you need to know is that to start this battery, you also have to pull enable signal to 3 volts, as I mentioned, and you need to provide a short, approximately 1 second long signal to the battery wake signal. So that's how the battery controller knows that the board is powered on, and there's a that the board Super I/O chip is operational and it actually sees the battery. Only after that it would communicate to a normal SPI data line. So this type of device is mm, I never seen such battery design before, but I think it's quite common on Microsoft Surface devices. So I think that would be the same on the tablet-like devices and many older. So I think all devices from the last 5 or 6 years should have the similar system. The second difference here is a MagSafe Live connector. So this is symmetrical. It has 6 terminals on each side. It provides some sort of adapter ID, and it also has LED integrated into the boards, which shows you the charging state, or if it's malfunctions, or it should blink or something like that. Um, so once we plugged in the charger, in this state we don't see anything. It won't charge unless keyboard is plugged in and unless SSD is plugged in. In fact, it has um, the circuit to check connections are present. So, for example, on the SSD drive, there's a signal which see if I can find here. So, so this one detection A, and there's also detection B, which should be pulled to ground. So detection B on the other side of the circuit. So these two signals, they indicate that SSD drive is properly seated. It's not like diagonally, it doesn't short anything. Only once it sees low level on both signals will it enable any DG hot state power supplies. So the second system here is FPC connector check. For example, on the same system on the keyboard connector, so you see there's key IP FPC connector detect B and A. So so it's kind of diagonally, not exactly, but still it checks if it's properly oriented, and also it checks if it's properly seated. So um, the next thing, so for now it doesn't, it won't charge, it won't generate any voltage once I plug the charger. So the next thing which happens once you plug in the charger, so obviously it won't turn on unless you have the LDO 30. So you don't have to try to turn it on without the battery, without providing this 3 volt signal, because most likely the Super I/O chip will not be operational. I've At least this particular board didn't turn on. However, on the circuit, I found the diode which which uses internal LDO or battery LDO 30 volts, but for some reason it didn't power on. Maybe I missed something. So the next thing to check is how our power supply operates. So let's connect the power supply and check here. So just need to tune it a little bit. So as you may see, the power supply provides pulses. So the peak would be the 10 volts. So these pulses are supposed to power up some systems on board because they have capacitors and so on, and would be enough to power up the system, which recognizes that everything is fine. So it checks if all connectors are present, if SSD is present, and only then it allows charging and power on board. So basically, you can override part of the circuit. So there's a special jumper here, which calls logic override, FPC logic detection override circuit. So this one so if you pull this one to ground, this will go into this XOR gate, and it will result with enable signal, but only a part of it, because as I mentioned before, there's also the signal in an SSD connector. So these two detection signals, detect A, detect B, they come from M.2 connector, and once the controller sees them, it sends the 3.3 VA enable CDGO signal, which then is, so there's the input here in this gate. So obviously we won't have the 3.3 VA enable signal unless we have all connectors seated and SSD drive. So for now, so let's see what it does. So I already put the jumper, so now it only needs SSD drive to turn on. And let's see what's happening here. So let's see that we have the normal voltage, 10 volts from the power supply. There's absolutely no problem with this device, but if I unplug the SSD drive, the device will turn a shutdown, and it will not even charge the battery, and there also will be no output from the battery. So this is kind of smart decision, because if you service this device, it's really hard to physically disconnect the battery. It also has the disconnect battery button, so battery shutdown button. It pulls down enable signal for a short moment, and it's enough for battery to go in standby mode, only providing 3.0 LDO line to the board. So this battery shutdown is actually printed on circuit board. It looks like a small battery with a cross. The cross is kind of separating the two copper parts. It just looks really neat, I think. So it's a really nice design here. So it looks exactly like that on board. So the other thing is how the power supply works. In my case, this was the most important thing, is how does it turn on power supply, because I figured how to charge the battery externally with an LBA1 battery repair tool. But after that, I figured that even fully assembled, it doesn't charge the battery. So it started digging deeper. So as I told you, there are 6 terminals here. So each side has ground, V plus, and connector detection pin. So if you plug it unevenly, for example, just one part is here, or if there's some problem with charger, there will be no voltage provided to this pins. So this detection pin is called SL1 HPD, hot plug detect probably 1A. There's also one on the other side, and there's actually I have the connector from the different laptop. This is the same connector, but this is from the Surface Pro, and it's the wires are exposed, so it's kind of crossing each other, and we have some middle. This is same V plus, and SL1 HPD2, SL1 HPD2 doubled, so it kind of covers both sides of the connector. So theoretically, it should pull down the. If you have water here, theoretically, it should pull down the 3 volt, which is supplied by this circuit. So let's check here. So this circuit supplies output for this HPD connector lines, and if we have some sort of water damage in the connector, it should probably pull 3 volt down, telling power supply that something is wrong, and it won't turn power supply. It will just provide pulses. So this is how it works. I hope it helps you to fix this thing, because there's nothing worse than fixing a working device, bringing only more damage by soldering stuff like replacing super I/O chips, thinking that's probably it's bad because if it's not charging, replacing battery controller and so on. Replacing battery, thinking it's bad because it's not opening any voltage. So once again, to turn on the battery, it needs active 3 volt enable signal, and it needs short battery wake signal for the battery, like one second long. It should be high on 3 volts. After that, the battery will communicate with the device and will provide output voltage. Battery, this detection pin is not necessary for the battery. This is from other side. It tells the device that battery is connected, so this is for the super I/O chip, so you don't need it if you work with battery repair tools or something like that. And the most important thing to know if you need to diagnose if the battery is bad or not. So if battery doesn't provide 3.0 voltage, you can try to fix it if you have proper tools for it, because it needs to be above lowest voltage on the BMC to start. But it's not clear to me if it will restore itself. If it's below this voltage, I don't think so, because the charging circuit in this particular device doesn't work if there's no 3.0 volts supplied from this battery. I'm not quite sure that it will be true for all devices. Need to check schematics for other things, because here I see like traces that they try to do it the way that it would work with both power supply and battery. So let's check this thing. As you may see, there's some sort of RTC supply source, there's a diode, which should in theory provide VCC RTC, but I'm not sure why, but this board wasn't powering on without the LDO from the battery. So that's it. I will also try to write a short article for the Wikipedia, because all this stuff is really hard to Google. I will also provide some pinouts from the connector. Basically, it's not that important from the connector, because if you are in process of fixing this device, you just check the voltage on coils here on the input, and you can see, obviously, if you are checking just power supply and you see this pulse-like signal, it doesn't mean that the charger is bad. It's simply how it works in the standby mode. It's very similar to the MacBook's sleeping mode on the MagSafe, because unless it has it sees some resistance to ground, I believe like 60 kilo ohm or something like that, it won't turn on. So it kind of looks if the very low voltage, something like 1.5 volts, will go to ground through this resistor. Once it sees that, it goes to 0.5 approximately. Only then would it turn on the power supply.